Good morning, students. Today we learn about big theta notations. In previous class, we are already explained about that big O notation and big omega notation. So big O notation is represent for upper bound of an algorithm. It can maximum time required to execute of an algorithm. But big omega notation is represent for lower bound of an algorithm. So it can very minimum time required to execute of an algorithm. So that is the concept of big omega and big O notations. So in this case, big theta notation is bounded to both two functions to form the big theta notation. So just to see the definition, theta notation gives a bound for function f of n to within a constant factor. So theta notation represents average time complexity. Average time complexity means the middle amount of time. That means the time lies between big O notation and big omega notation. So average time means the specification, that means the middle time required to execute of an algorithm, that is average case time complexity. Okay, just to draw the diagram, just wait. Diagram, so this is a diagram. So x-axis can carry n, that means input n, and y-axis can carry time. Then after to draw the function is f of n. Okay, so this is function. Upper bound, that means the above of f of function is called upper bound. Okay, then below of f of n is called lower bound. Okay, so upper bound means big O of g of n. Okay, then lower bound of an algorithm is represent big omega of g of n. So this is the omega notation concept. Okay, so this is a function. Actually, what is the name of this function? This function is theta, big theta notation, big theta notation. So big theta notation is lies between omega, big omega notation and big O notation. Okay, so this is a concept. So actually, what is the definition is given here? Both founds are bounded to form a big theta notation. So that is the concept. Okay, then so this big theta notation is also represent for average case time complexity. So you already know about what is average case time complexity. Is a specific time, otherwise middle time, that means average time complexity. Okay, then after to define the mathematical tool, mathematical function, that means f of n, we can write f of n equal theta of g of n. So how can write the theta notation? That means normally f of n is a function name, so we can write f of n equal theta of g of n. So that is a function name representation. Then after, what are the positive constants? That means n0, c1 and c2. So these are the positive constants used in big theta notation. Okay, so n0 is right format of big theta notation. That means the function f of n is always lies between c1 g of n and c2 g of n. Okay, so just to see the diagram, so this is f of n. So this is a function theta notation. The theta notation lies between c1 g of n and c2 g of n. So we want to explain the function lies between c1 g of n and c2 g of n. So that is a concept. Then after two specific criteria is given here, then how can define the definition using mathematical function? Okay, so theta of g of n equal f of n, that means there exists positive constants c1, c2 and n0, such that, so this is the criteria. Okay, so what is the criteria? C0 is less than or equal to c1 g of n is less than or equal to f of n is less than or equal to c2 g of n for all n is greater than or equal to n0. Okay, so that is a condition. So this function f of n c2, so this is represent for this much of portion is represent for what? Big O notation, big O notation, big O notation. So this case f of n is f of n is that means c f of n is less than or equal to c1 g of n. Okay, so this is big omega, big omega concept, big omega concept. So this is a criteria. So these two criteria is also satisfied in this case. Okay, so that is the criteria. Then after to use any mathematical example, that means to take a polynomial example, after to prove that this condition. Okay, what is the condition? F of n is less than or equal to c1 g of n and c2 g of n. You must satisfy that condition. Then n is greater than n0, so that is always all asymptotic notation to satisfy this condition. N is greater than or equal to n naught. Then if you need, you can take any one example about this concept, otherwise no need. Okay, in the previous two cases also prove that some example is there. Then theta notation is not given here. Then if you need, you can take, otherwise no need. Okay, then go to next concept, little o notation. Little o notation. Okay, so the main asymptotic notation is big O notation, big omega notation and big theta notation. So these are the three notations commonly used in asymptotic notation. So we want to use additional some notation is there, so that is little o notation and little omega notation. Okay, so now what is little o notation? Okay, so there are some notations present except big O, big omega and big theta notation, that is little o notation. Okay, little o notation is used to describe upper bound that cannot be tight. In other words, loose upper bound of f of n. So upper bound, that means weaker upper bound. Okay, so little o notation is represent for weaker upper bound of an algorithm. Okay, so that is not tight, it is a loose upper bound of an algorithm, because big O notation is represent for upper bound of an algorithm, but little o notation is weaker upper bound of an algorithm. Okay, so the function is represent f of n is a function. Okay, so f of n equal small o of g of n. Okay, so we can write the function f of n equal then small o of g of n. Okay, so that is the little o notation function representation. Okay, so we can write the function like this, or all asymptotic notations. How can write the function? F of n is the function, then after to whatever you may be. Okay, then let f of n and g of n are the two positive functions, that is the real numbers. So we can write the function is little o of g of n. If any real positive constant, so here take the constant is c, and to satisfy two conditions are there. What is that? N naught is less than or equal to 1, such that f of n is greater than 0. Okay, so that is the condition. That means the function must satisfy these two conditions. Then after to specify the mathematical function. Okay, to take the little o notation. Okay, how can write this? Then first you write the function f of n equal small o of g of n. Okay, that means what? That is limit n extend to infinity f of n by g of n equals 0. So we must prove this formula. Okay, prove this formula. That means limit n extend to f of n divided by g of n equal 0. So that is the concept. Okay, then after we must satisfy this mathematical function. Okay, then here listen here, if f of n equal n square and g of n equal n raised to 3, then check whether f of n equal little o of g of n or not. Okay, then here two function is given here, f of n and g of n is the two function. Then after to give values, that means f of n equal n square and g of n equal n raised to 3. Then after to check the condition, what is the condition? Limit n extend to infinity f of n by g of n equal 0. That means all infinity concept equal 0. We must satisfy that condition. Okay, then after to use the value. Okay, use the value, then that means using the formula. Then n square means f of n, then n raised to 3 means g of n. Okay, then substitute the values of f of n and g of n. Okay, so we can substitute this value. Then after, to simplify the concept, then n square by n3, that means 1 by n. We can get the simplify reduced value of n square divided by n raised to 3, that is 1 by n. That is a reduced value of above formula. Okay, so that is limit n extend to 1 by n. Then after 1 by infinity, that means infinity upon any value you can get the 0 concept. So that is the reduced format of the given formula. Okay, the result is 0 and satisfy the equation. So f of n equal little o of g of n is satisfied. Okay, then after to explain about this diagram, then with the graphical concept of little o notation, then we can take two functions f of n and g of n. Then after, here the two curves are so independently, that means, so here the two curves is a our weaker upper bound of an algorithm. So this is as usual, n is taken x-axis and y is take from x-axis, then y-axis. Okay, is correct. Then after two, meeting point is n naught, n is always greater than n naught. Okay, then f of n is less than n g of n. Okay, so there is three concept is given here. So sorry, two concept is given here. Okay, so that is little o asymptotic notation. Okay, then after go to omega notation. Okay, little omega notation. There are some other notations present except big O and big omega and big theta notations. Then the additional notation of little omega notation is one of them. Then after, what is that? So little omega notation is just reverse of little o notation. So actually, what is the function is there? Okay, what are the constants using here? Okay, so then after to define the concept. So little omega notation used to describe the weaker bound algorithm. Okay, weaker bound algorithm. So big omega notation is represent for lower bound of an algorithm, and it is satisfy best case time complexity because it can take minimum time. So little omega notation is just similar to big omega notation, but what is the difference actually here? This is a weaker lower bound. Okay, weaker lower bound of algorithm. So here is also to specify two functions are there, f of n and g of are the two functions. Then how can write the function? Then f of n equal omega of g of n. Omega of g of n is a function representation using little omega notation. Then after to specify condition, so what is the condition? So here to use the positive constant, c is greater than 0. So constant is here, two constants are using here, c and n naught. C is greater than 0 and n naught is also greater than 0. So these are the two constant criteria are given here. Then after, to satisfy the condition, so we must satisfy the condition is, what is the criteria condition using for little omega notation? What is that? 0 is less than or equal to c g of n is less than or equal to f of n. So that is the condition, just reverse of little o notation. G of n is less than or equal to f of n. Then after, as usual, all asymptotic notation using this same concept. What is that? N is greater than or equal to n naught. So all 5 asymptotic notations are described given here. So all asymptotic notations satisfy this condition, that is n is greater than or equal to n0. So in this case, little omega notation, 0 is less than or equal to cg of n is less than or equal to f of n. Then after that, using the mathematical function to explain the concept such that limit x tend to infinity g of n by f of n. So in little omega, f of n by g of n. In little little o notation, f of n by g of n. In little omega, g of n by f of n equal to 0. Okay, so that is the mathematical function. Then after, to substitute the value, then omega n equal 3n, then f of n equal 3n, because f of n equal omega of g of n. So they both are equal. So we want to write f of n equal 3n. then after g of n equal 1. Okay, so here take two values 3n and 1. Okay, 3n equal to f of n and gn equal to 1. Then after substitute the value, limit n extend to infinity, g of n divided by f of n equals 0. So that is a function. Okay, then after substitute the value, so limit n extend to infinity 1 by 3n. Okay, 1 means g of n and f of n equal 3n. So then after equal to 0, so anything upon infinity is 0. So that is the concept. Okay, so the criteria is satisfied in this case. Okay, so this is little omega notation. So little omega notation is over. So asymptotic notation is over. Okay, so I think you can understand this concept. Then if you have any doubt, then you can clear through the Google Meet. Okay, thank you.